So in this video, I'm going to talk about trigonometric integrals involving tangent and secant, but, well, okay, first of all, this is like a whole series. So in the first video, I talked about powers of sine and cosine. In the second video, I talked about square roots and products of sine and cosine. So this video, I'm going to talk about, like I said, tangent and secant. So that's all we're going to focus on in this video. But the thing is, these ideas can also be extended to cotangent and cosecant. So very often with integration and derivatives, right? So tangent and secant go together and cotangent and cosecant go together. So this is all big one happy family for this video. So for these, so we generally use the Pythagorean identities to help evaluate these types of functions. So the thing is, and maybe this is true for you too, but I have trouble remembering the order of those Pythagorean identities. I mean, I know I like do this for a living, but I swear I have the memory of a hamster on some things. So there is a little hack if you are in that boat where it's like, okay, I don't remember what they are. Most people remember sine squared x plus cosine squared x equals 1. So to get the other two identities, really all you have to do is divide by either sine squared or cosine squared to find the others. So I'm mentioning this because this is like a thing that you've got to be able to bust out regularly. And some people are just visual people and they just need to write down the identities. And so if you're one of those people where it's just easier if you have the identities in front of you, then just go ahead and derive them at the beginning of exams or quizzes or whatever you're using this for, and then you can easily reference it. So let's talk about this then. So first, I'm just going to show you what it means to divide everything by sine squared. So, of course, if I divide sine squared by sine squared, I get 1. Cosine squared over sine squared is cotangent squared, and then 1 over cosecant, or 1 over sine squared is cosecant squared. So that gets us to one of the Pythagorean identities. And then if we wanted to do the other one, so then I could just divide everything by cosine squared, and then this will become tangent squared plus 1 equals secant squared. So that's just a quick hack if you forget that. Okay, so those are basically the identities that we are going to use to help us with these problems. So as far as like, so how do I evaluate these? So let's start with like tangent cubed x. So if you've been following along with this series, so one of the things that we've seen is like with odd powers, a lot of times we want to break this up so that you have kind of this like 2k plus 1 form is what I like to call it. So the gut feeling that I get from this is that I probably want to split this up into as many even powers of tangent as I possibly can, and then that leftover one that makes it odd. So this is very often kind of where you want to start, and then you kind of start working through these even powers. Now in this case, tangent squared, at this point I can already rewrite this, right? So I can use the identities. Those are the two that we just discussed. So I need to use this for tangent. So obviously I need to subtract 1 in this case. So this will turn into, secant squared x minus 1. And then I've got this tangent x dx. Okay, so from here, now you kind of just have to finagle and finesse your way through the rest of this. So what I'm going to do is I'm actually going to distribute that tangent so that I have secant squared x, tangent x, and then let's see, let's break this into 2 separate integrals even. And then I'll minus tangent x dx. Okay, so these are 2 separate integrals, so let's make some space. Okay, now there's actually more than one way to evaluate this integral. So I will tell you the way that I'm planning to go with it. So I want to use substitution. So what's interesting about this particular integral, so there's actually 2 different ways that you can do the substitution. So I would actually like to challenge you to see if you can figure out what those 2 ways are. Write them down and play when you're ready. So you can either set u equal to tangent of x or u equal to secant of x. So this is an interesting integral, and this happens sometimes with trig integrals where you could go either way. And I actually want to take a moment, so I'm only going to focus on this integral for a second because this is worth a discussion. So I want to evaluate this both ways, okay? So here's what we're going to do. So in this first case, so my u is tangent, so my du is secant squared x dx. And for the second one, my du will be secant x tangent x dx. Okay, so let's go ahead and evaluate each integral. So this will be u du, and this one will also be u du. And so now if I integrate for both of these, obviously I get the same u integral. But what's interesting about this is that when I plug my function back in, I get two different integrals, which at first you might be like, ruh-roh. But okay, here's the deal. Which one is right? They're actually both right. If you take the derivative of either one of these, you will get back to this. So they're actually both right. And so this is a weird thing that can happen with some trig integrals. And it's actually important that you know that this is a thing that can happen, because, sometimes when you're looking at, if you're looking up like a solution or you're trying to figure something out, you might be told that this is what was right and this might be what you have. So you also have to now, you're getting to like a level in calculus where you've got to be able to interpret, if the form of your answer is correct. And this one is, I think, actually kind of a genuinely tricky one. But yeah, they are actually the same thing. So which one do we like better? I think I like this one better. So I'm going to use that one. So I'm going to make some space. And I will just go ahead and write this as 1/2 secant squared x. So I'm just going to leave that alone. So now let's talk about the other integrals. So this is tangent of x. So there's also a couple ways that this one can turn out. So this is kind of a fun integral to talk about. So you can either memorize this integral, which I would recommend that you do in the long term for a calculus class. This is just handy to know. But if you forget the integral of tangent, you can always just figure it out like this. So you set it up as sine over cosine. But the thing is, there's actually more than one form of the answer also for this integral. So for this case, so now my u will be cosine, and my du will be negative sine x dx. So I can go ahead and transfer that negative to the other side. Okay, and so now if I set this up, so let's just focus on this right now. I'll come back to the gold part later. Okay, so I've got this negative and this negative here, so that's going to turn this into a positive. So this will become the integral of 1 over u du. So that's going to equal the natural log of u. So that's going to be the natural log of cosine of x. Okay, so there's the integral that I found. But a lot of times if you look up what this integral actually is, the value of the integral, the other value that you could get would be negative natural log of cosine x, which then I can use properties of logarithms to transfer that into here so that this becomes the natural log of 1 over cosine x, which is then the natural log of secant x. Now, in this case, the negative that I had here, I let it transfer. So remember I had this negative, I had this negative sign. So what ended up happening, right, is that I said this and this create a positive. So I didn't get the negative here like normal. But if I had not paid attention to this here and I just focused on, so maybe just to make it clear, if I had just focused on, see, this part of the integral, then I would have gotten this answer here. And so then I would still have minus natural log of secant x. So there's two answers that will suffice. So I'll let me make some space and I'll write them down. Okay, so we have this 1/2 secant squared x, which we said already had another form. So I could either have plus the natural log of cosine x plus c, or I could have had minus the natural log of secant x plus c. Or I could have had, right, this could have been tangent squared. So they're actually all equivalent. So that is fun, right? So, okay, cool. So there's one integral down. I have a couple more that I want to talk about. So next I want to talk about just something to the fourth power. So I've got secant to the fourth x. Okay, so for this one, so we need to once again think about, so what can we actually like evaluate here? And so these tangent, secant, cosecant, cotangent integrals, so these are going to require just a little bit of like playing around. You will eventually develop a sense for them, but I really want to encourage you to just kind of be comfortable with the fact that you might not see exactly what you need to do. So I actually didn't work this one out in advance. So a lot of times when I make lessons for you guys, I work them out in advance, but I'm just going to show you kind of how I think about this. Okay, so one thing that I know is that the derivative of tangent x is going to be equal to secant squared x. Then of course the derivative of secant x is secant tangent. I think about these relationships when I'm setting up my substitution. So when I think about what am I going to do with this secant to the fourth, I actually want to keep a secant squared for the sake of my substitution, right? Because I know when I set my u, my du could equal secant squared. So what I'm going to do is I'm just going to play around with this. I'm going to first write this out as secant squared x, secant squared x. And then I will go ahead and use my handy dandy identities from earlier, so I can use this little property here. So secant squared I can rewrite as 1 plus tangent squared. So I'm going to do that. So this is going to be 1 plus tangent squared x secant squared x dx. And now I can already see like where the substitution can go. So like as far as how do you break up the trig integrals, so a lot of it is thinking about what derivatives do you know, what integrals do you know, and then is there like a strategic way to break things up using the identities. So it's really a lot of like playing around and just kind of seeing what's going to work. And you know what else works like that, where you just play around and see what works and figure it out? Literally all of science and engineering. So I always love talking about integrals because I feel like it's like one of the simplest ways just to introduce you to that type of thinking that you need of like just figuring it out, even if there's not like a clear path forward. So, okay, so now let's talk about the substitution. So in this case, so my u now can be tangent x, so that my du can be that secant squared x dx. And so then we get this just lovely, simple integral, 1 plus u squared du. Fantastic. And so then this will be u plus 1/3 u cubed plus c. So this is tangent x plus 1/3 tangent cubed x plus c. And so that's it for that one. And I figured that we would just end this video working with cotangent and cosecant, just so you could kind of compare. But it's really the same ideas, right? So we are still using just the Pythagorean identities that we have. So I'll use probably this one here. And so I have this combination of even powers in this case. So we're going to have to just kind of think about what makes sense here. But again, just thinking about derivatives, these are like the relationships that I know exist. So I might also be trying to leverage those. Now, what I would recommend here is just for you to give this a shot of trying a couple things. Now, even if your first idea doesn't work, I really would love it if you would try something else, because the only way you get good with problem solving is to just keep making yourself uncomfortable and learn from your mistakes. It's much better for you to make mistakes than to watch somebody do it perfectly every single time. That is the way that I learned calculus. That's the way a lot of people learn calculus. And that's actually how a lot of people just figure things out, is they just try something and then they try something again. So try to make a more educated guess if you have to try it again, but hit play when you're ready. Okay, so again, I have not worked out anything in advance here, okay? So the one thing that I'm thinking of that I want to leverage is, once again, so since I know that cotangent, the derivative of cotangent is negative cosecant squared, my spider sense is telling me that I probably want to leave a cosecant squared here. So I am going to break this up into cotangent squared x, cosecant squared x and cosecant squared x dx. So I just broke up that cosecant squared. But now I can go ahead and I can use my Pythagorean identity. So remember that cosecant squared x is 1 plus cotangent squared. So that feels like the right direction. So this is going to become cotangent squared x, 1 plus cotangent squared x, and then cosecant squared x dx. So now what I'm going to do is I'm just going to go ahead and distribute everything. So this is going to be cotangent squared x, cosecant squared x dx. I'm just going to break into, I'll do the same integral. And then cotangent to the fourth x, cosecant squared x dx. Cool. So now my u can just be cotangent. Remember, the derivative of cotangent is cosecant squared. Negative cosecant squared. So this will be negative cosecant squared x. So I'll just rewrite this as negative du equals cosecant squared x dx. We need some space, so I'll make some space. Okay, so we can make our substitutions then. So this will be u squared. I'm going to break this into two separate integrals. Du minus u to the fourth du. And then let's see. Oh, I forgot the negative. So there should be a negative here that goes in front. So this will become a negative. This will become a positive. Oh, no, this should also be negative. Okay, there. Got all my signs right. Sometimes the signs are the hardest parts of these. Okay, so now this will be negative 1/3 u cubed minus 1/5 u to the fifth plus c. So this will be negative 1/3 cotangent cubed x minus 1/5 cotangent to the fifth x plus c. And we got that one. Okay. So if you found that helpful, I'd love it if you hit that like button, maybe the subscribe button, or leave me a comment. And otherwise, I am going to leave it at that, guys. I do have other example videos if you want to see more examples on the same topic. But I'll talk to you guys in another video. Bye!